Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody. We are from Group 5. We will present the result of our group discussion on the theme of pest monitoring and sampling. But first, let me introduce the names of the members of our group, namely Hamidatus, Marlena Hilda, Fatimah Nur Azizah, Nurul. I'm Marlena, as the moderator of Group 5, will guide the course of this discussion. Let's move to the next session, which is a material presentation session that will be conveyed by my friends. Time and place are welcome.
Introduction. Monitoring as a basis for making pest control decisions in IPM. Sample is part of a population of organisms. The total number of individual organisms present in a place at a certain time. Monitoring is an observation activity that is carried out periodically on an object in a certain location for the purpose of making decisions. Ecosystem monitoring in the application of IPM is an activity that will determine success in making decisions about pest control. The target of agro-ecosystem management requires information on the condition of the ecosystem obtained from monitoring activities so that the target can be achieved properly. The information is then analyzed and the result of this analysis become a reference for farmers in making decisions regarding what management actions are needed in ecosystem management, including pest control.
A relationship between sampling and monitoring program. The first activities carried out is ecosystem monitoring. Monitoring activities are carried out to follow the development of the state of the ecosystem at a time, which includes the development of ecosystem components. Both biotic components such as plant condition, the level of plant damage by pest and disease, population, natural enemy, population, and others. Also abiotic components such as temperature, rainfall, wetness, etc. Monitoring results or monitoring data are analyzed among others by comparing ecosystem data with the AE value or control threshold. From the result of ecosystem analysis, the decision can be made regarding control or management action that need to be applied to the ecosystem. The result of decision making are immediately applied to the field regarding management or control actions such as improving crop cultivation, introducing natural enemies, changing their habitat, controlling with pesticide. Decision makers are getting lower, namely on the management side of the agriculture ecosystem, such as farmers or farmers group. In observation and sampling, there are two conditions that must be considered, namely, one, practical, meaning it is easy to work with, does not require expensive tools and material, and does not take a long time. B, reliable, meaning it can represent the true population picture.
B. Factor that cause error in sampling. Number one is the nature and skills of the observers. addressed by training observers in the fight and providing quid box. Number 2 is local environmental condition, addressed by sampling adjust for pest behavior. Number 3 is the nature of the spatial distribution of insect is seen from the mean and standard deviation per sample unit. Mean together with standard deviation random mean greater than standard deviation regular, mean smaller than standard deviation cluster.
C is sampling methods. The insect community of an area can be identified by sampling, which is initial stage in the data collection process. The technique using in sampling will affect the value of the sample to be used in analysis discussion. According to Untung 2006, there are three main sampling points. The first one is absolute method. Generate population estimates in the form of abundance per unit of cell surface or insect habitat of cells. This method is the best sampling method because it has high accuracy. The data obtained in the absolute method are in the form of first, absolute population, which is the number of insects per unit area. Second, population intensity, which shows the number of insects per habitat unit, such as per ant, per stem, per root, as well as. The third one is base population, usually using a unit of measurement between absolute and intensity, for example, 1 meter per kg of the plant surface. The absolute method has this advantage that it requires a lot of money, time, and energy, especially for extracting the collected insects. Next. The second method is the relative method. In relative method, the measured population is not known for its unit. It is only displayed in the form of a comparison in space and time, usually used over large areas or study insect activity. In this method, several types of traps are used, such as pitfall trap, sticky traps, pit traps, lamp traps, or using other tools such as insect nets fly. The advantage of these methods are that it is easier and more practical than other methods, and is more practical because generally individual insects are easier to catch. The relative method has drawbacks, namely a low level of accuracy because it is influenced by environmental conditions around the trap and the skill of the observer when collecting insects, so that it cannot be used as an estimate of the actual population. This method is also not recommended for sampling insects that require high accuracy. The third method is population index method. In the population index method, measurements are made of products left by insects or the influence of insects, not insects. The products left behind by these insects can be in the form of feces, cocoons, and nests. An example is calculating the number of red pests. What is count in the number of burrows? The population index method that is most often used in observing the damage or consequence of pest attack that occur on the affected plants. The advantage of the population index method it practically implementation, especially in making decisions and estimating the value of crop damage. The disadvantage of this method is it is low accuracy because the population index collected is not the number of population, so it cannot be used as an estimator. However, due to its practically the population index can still be used in the sampling method to assist in making decisions and estimating the value of plant damage suffered.
And the next is development of sampling program. Sampling with a fixed sample size requires a large amount of money, observers, and observation time. As a result for the number of available personnel and cost, the coverage area of the observation program is limited, and the conclusion-making process takes longer. To speed up the decision-making process based on observation, a more practical sampling technique is needed and less time-consuming. One of the sampling techniques that meet these requirements is the consecutive sampling technique. In contrast to conventional sampling techniques, which require a fixed number of sample units for each observation, continuous sampling does not require it because the number of sample units is determined by the density of the pest population. Control decision making. The decision can be the form of need control if the pest population is high or not need control if the population is low. Thus saving cost and time because the number of sample units examined is less. If the pest population density is moderate, the number of sample units observed will be more. Compared with conventional sampling with a fixed sample size, continuous sampling can save cost, time, and observation effort without sacrificing accuracy, and continuous sampling programs for certain pests require basic information obtained from research activities. All right, let's move to the last session of the discussion, which is closing. That's the result of the discussion of Group 5. We apologize if there are many mistakes. Wassalamualaikum warahmatullahi wabarakatuh.